Section 5.7, we are looking at roots and zeros, so we want to be able to find the zeros of the polynomial function. So again, this is where it crosses the x-axis or the solution to any type of polynomial function. So we have a couple theorems here. We have the complex conjugate theorem, which states if there's an imaginary number as a zero of a function, then its conjugate is also a zero. So they always have to come in pairs. And if you don't remember what conjugate is, that is where the real part stays the same and imaginary part switches signs. Okay, so then we have some steps of how we're actually going to solve these polynomials. So step 1 is identify the degree. That's how many zeros we have to find. Step 2, we're going to type it into the y equals in the calculator and look at the table and identify any spots where y is equal to 0. So that's where our zeros are, is when the y value is equal to 0. That's when it would be crossing the x-axis. In step 3, we're going to use synthetic division to divide those off. And then step 4, once you have the polynomial down to degree 2, then we can use square roots or the quadratic formula to find the last two. So on here, we have a 4th degree, so that means I'm going to have to find a total of 4 zeros. So I'm going to go to my y equals on my calculator, or if you're doing it on the computer, typing it into Desmos. And I'm going to look at my table here. So I can see from this table at -4 I have a 0, and at +4 I have a 0. And if I just scroll through a little bit more, it doesn't look like I'm getting any more than that off of my table. So I found 2 of them on here. So I'm going to make a list of them up here. I have -4 and +4, so there's 2 of them. So my next step is I'm going to divide these off using the synthetic division. So I'm going to start with -4, and I'm going to line up the coefficients. So I have a 1. I need 3 placeholders here. I need one for the cubed term, the squared term, and the x term. So now I'm going to do my multiply and add here. So this would give me 16 is 64. So you can see that is a factor there. So I divided off the one of them. Now I'm actually going to write onto this. I'm going to add on this other 0 that I know is a root because of looking at the calculator. And I'm going to divide that one off now. So I divided one of them off. This lowered the degree. This would be 3rd degree now. Now I'm going to use this one. So that would give me a 4, a 0. So now I'm down to a quadratic, which these we've been solving since Algebra 1. So this would be x squared plus 0x plus 16, or just x squared plus 16 equals 0. So if I were to solve this, I would subtract 16 from both sides, and then take the square root. So we would have positive and negative square root of -16. And when you have the negative underneath of the root, that becomes I. And the square root of 16 is 4. So I would have -4i and +4i also. So these would be all 4 of the zeros for this function. Okay, now I also want to show you another way to do this one. So if you're running out of room, sorry, just pause and grab another sheet of paper to write this down on. So another way to do this would be what we practiced before of writing them as quadratics. So I could write this as x squared squared minus 256. Now 256 is a perfect square. That is, the square root of that is 16. So I can write this as, well, let's do this. Let's say that I'm going to say u equals x squared. So then I have u minus 256 equals 0. Sorry, u squared. Now this is a difference of squares, so I can say u plus 16 and u minus 16. So if I solve both of these, I would have u equals negative 16, u equals positive 16. But we also know that this is actually the x squared. So if I take the square root of both of these, then this one would give me the positive and negative 4, and this one would give me the positive and negative 4i. So either way that you do it, you get the same answers there, just showing you kind of two different methods that you could attack this. Alright, example 2. So looking at this, I can see that it's third degree, so I'm going to have to find 3 zeros. So the first thing I'm going to do is I'm going to type it in the calculator and look at it. You can also look at them and see right away if it looks like there's anything that could be factored out or any way that you could factor it. And I'm going to my table. So right here I have a 0 at negative 1. And it looks like that's the only one I'm going to find on the calculator. So I'm going to list that one. And now I'm going to use synthetic division to divide that off. So I would have 1, negative 1, 2, and 4. 1 time, that would be here. Okay, so what I'm left with here is quadratic, so x squared minus 2x plus 4 equals 0. And then looking at this, it doesn't look like I have any way that I can factor that, so I'm going to have to use the quadratic formula. So I like to start with the discriminant first, so negative 2 squared. And that gives me negative 12. So the rest of my quadratic formula then would be negative b, so plus or minus the square root of negative 12 over 2 times a, so over 2. So now I got to split this up. So this would become, I have a negative 1, a 4, and a 3, which if you can do that all in one step and you can skip this part, that's fine. So this would be 2i root 3 over 2. And then since these three things are all divisible by 2, I'm going to divide those and it's going to become 1 plus or minus I root 3. So those are my other two zeros then. So if I list those back out up here, I'd have 1 plus I root 3 and 1 minus I root 3. Alright, one more example. So it says, write a polynomial function of least degree with integral coefficients where the zeros of the function include 4 and 4 minus I. So if I have a 0 at 4, what I'm doing is going to put these into factors here. So what this really means is this is an x minus 4. And then if I have one at 4 minus I, then that is the same thing as saying x minus, 4 minus I. And I also need, this was that complex conjugate theorem from the beginning, since they always come in pairs, that means 4 plus I is also a root. So I would have x minus 4 plus I. I feel like I have extra parentheses there. I do right here. Alright, so we're going to simplify these then. So in here, this is going to be the stuff I'm going to simplify first. So this is going to just stay the same for now. Inside of here, this is going to become x minus 4 plus I, x minus 4 minus I. And then these I'm going to multiply together. So you can distribute, or I would set up a box, a 3 by 3 box here. So you're going to have an x, a minus 4, and an x, a minus 4, and an I, minus I. And we're going to multiply into each of those boxes. Okay, so looking at what I get here, combining like terms and whatnot, I have an x squared. I have these two, which will become negative 8x. I have a positive xi and a negative xi, so those will cancel each other out. I have a positive 4i and a negative 4i, so those will cancel out. And if you remember what I squared is equal to negative 1, so I have a negative negative 1, which equals positive 1 here, so those will combine and make 17. So then I'm going to take this and multiply it by this original x minus 4 that we had over here. And I would set up a box for this. So this would be x cubed. And 17 times 4, I don't remember that off the top of my head, 68. So if I combine any like terms, I have an x cubed minus 12x squared. This would be 49x plus 68. So this would be the function that would have these as zeros. So the zeros of this would be the 4 that we used here, and then the 4 minus I and the 4 plus I that would come out of that. Okay, so try these last two here. And for your joke of the day, why did the belt go to jail? It's because it held up a pair of pants. Okay, I hope you have a great rest of your day, and make sure you're kind to someone today.